There are objects in the universe that do not merely exist. They disturb. They stretch the fabric of reality until our equations begin to fail. Places where gravity is no longer a force, but a verdict. Where time slows to a crawl. Where light itself is bent, drained, and finally erased. For decades, we believed we understood the limits of black holes, how massive they could become, how fast they could grow, how early they could appear. And then, we found one that broke all of those assumptions. A black hole so vast that it doesn't just dominate its galaxy, it challenges the history of the universe itself. If you enjoy calm, careful explorations of ideas like this, where we slow down and let the universe speak for itself, you might want to like the video and subscribe. It helps the channel continue moving forward. This object is not famous because it is violent, not because it is close, but because it should not exist at all. Its mass defies our models. Its age defies our timelines. Its scale defies intuition. Astronomers gave it a simple name, cold, technical, almost harmless. Ton 618. But behind that name lies one of the most extreme objects ever discovered. A black hole with the mass of tens of billions of suns, seen not as it is today, but as it was when the universe was still young. A relic from an era when galaxies were forming, when matter had barely settled, and when nothing should have had enough time to grow this large. Ton 618 is not just a record holder. It is a question, a crack in our understanding, a reminder that the universe is under no obligation to follow the stories we tell about it. And to understand why this black hole is such a problem, we have to go back to the moment it was first seen. Not as a monster, but as a faint blue point of light on a photographic plate. Part 1. A star that wasn't a star. In the late 1950s, astronomy was still a quieter science. No space telescopes, no digital sky surveys, no automated alerts. The universe revealed itself slowly, on photographic plates developed by hand. In 1957, astronomers working at the Tonantzintla Observatory in Mexico cataloged a faint blue object near the border of two constellations, Canis Venatici and Coma Berenices. It was labeled simply as another entry in a long list, Ton 618. At first glance, there was nothing special about it. It looked like a star, dim, blue, unremarkable. No dramatic brightness, no visible structure, no reason to suspect it was anything extraordinary. But astronomy has a habit of hiding its most extreme objects behind ordinary appearances. When scientists later studied the light from Ton 618 more carefully, they noticed something was wrong. Its spectrum didn't match a star. The light was stretched, shifted toward red wavelengths, not by motion through space alone, but by the expansion of the universe itself. Ton 618 was not nearby. It was unimaginably distant, so distant that the light reaching Earth had begun its journey billions of years ago. Further analysis revealed the truth. This was not a star at all. It was the blazing core of a distant galaxy. A quasar, one of the brightest and most energetic phenomena the universe can produce. At its center was not nuclear fusion, but something far more extreme. A supermassive black hole feeding on colossal amounts of matter. What appeared as a faint point of blue light was, in reality, a cosmic lighthouse, a signal from the early universe. And as astronomers refined their measurements, the numbers became unsettling. Ton 618 was not just distant, it was not just luminous, it was massive on a scale that should have been impossible for its age. Before anyone asked what it was, a more troubling question emerged. How could something like this have formed so early? To answer that, we first need to understand how far away TON 618 really is, because distance, in this case, is not just space, it is time. Part 2. A message from the young universe. When we talk about distance in space, we usually imagine separation, a gap between two places. But in cosmology, distance also means time. TON 618 is located more than 10 billion light-years away in straight-line distance. But because the universe has been expanding the entire time that light was traveling, its true separation from us today is closer to 18 billion light-years. This isn't a contradiction, it's a result of space itself stretching while the light was already on its way. That means every photon we detect from TON 618 left its source when the universe was less than a quarter of its current age, long before the Milky Way looked the way it does now, long before Earth existed, long before our Sun had even formed. We are not observing TON 618 as it is, we are observing a memory. A snapshot from a time when galaxies were still assembling, when matter was denser, hotter, and far more chaotic. At that stage in cosmic history, most galaxies were small, messy, unstable. Star formation was intense, collisions were common, and supermassive black holes were only beginning their long process of growth. At least, that is what our models predicted. TON 618 does not fit comfortably into that picture, because even in the early universe, black holes should grow gradually. They are limited by how fast matter can fall in, by radiation pressure, by angular momentum, by time itself. Yet here we see a black hole that already weighs tens of billions of times more than the Sun. At an age of the universe when there should not have been enough time to build something so large. The light from TON 618 carries more than energy. It carries a contradiction. It tells us that somewhere in the early universe, matter collapsed, fed, and grew far more efficiently than our theories allow. And the only reason we can see this contradiction at all is because TON 618 is not a quiet object. It is screaming across the cosmos. Not in sound, but in light. Because TON 618 is powered by one of the most extreme engines nature has ever constructed, a quasar. To understand why this black hole is visible across the universe, we need to understand what a quasar really is. Part 3. The brightest beacons ever built. A quasar is not an object. It is a process, one of the most violent, efficient, and luminous processes the universe allows. At the center of a quasar sits a supermassive black hole, not visible, not glowing, perfectly dark. But surrounding it is something else entirely, a vast disk of gas and dust spiraling inward. This is the accretion disk. Matter inside it does not fall straight down. It twists, shears, collides. Friction heats it to tens of thousands of degrees, in some regions, millions. As the material accelerates, it approaches the speed of light, not crossing the limit, but pressing against it. The result is radiation, enormous amounts of it, from radio waves to infrared to visible light to X-rays and gamma rays. The accretion disk alone can outshine an entire galaxy of hundreds of billions of stars. But the disk is not the end of the story. As matter spirals inward, magnetic fields become twisted and compressed. They coil like springs. And when they snap, they launch jets. Twin beams of plasma erupt from the poles of the black hole. These relativistic jets are fired outward at nearly the speed of light. They do not fade quickly. They do not stop at the edge of the galaxy. Some extend for millions of light years, longer than entire galaxies. The energy carried by these jets is enough to reshape their surroundings. They can heat interstellar gas, blow it away, shut down star formation. In extreme cases, they can decide the fate of the entire galaxy that hosts them. This is why quasars are not just bright, they are transformative. They are the universe announcing itself across unimaginable distances. TON 618 is one of the most luminous quasars ever discovered. Its energy output matches the combined light of roughly 100 trillion suns, not stars, suns. And that brightness is the only reason we can see it at all. Because without the quasar, the black hole itself would be completely invisible. But light alone does not tell the full story, because at the heart of this blazing beacon lies something far more unsettling. A black hole so massive that even among quasars, TON 618 stands apart. To understand just how extreme it is, we need to compare it to something closer, something familiar. The black hole at the center of our own galaxy. Part 4. If TON 618 replaced the heart of the Milky Way. At the center of our galaxy lies a black hole, Sagittarius A star. It has a mass of about 4 million suns. By everyday standards, it is enormous. It shapes the orbits of stars around it. It anchors the Milky Way. But on cosmic scales, Sagittarius A star is modest. Now compare it to TON 618. TON 618 is estimated to have a mass of roughly 66 billion suns. That makes it more than 16,000 times heavier than the black hole at the center of our galaxy. This is not a difference of degree, it is a difference of category. If Sagittarius A star were a grain of sand, TON 618 would be a mountain. This isn't a difference of scale, it's a different regime of physics. The event horizon of TON 618, the boundary beyond which nothing can escape, is staggeringly large. Its diameter is estimated to be over 400 billion kilometers. To put that in perspective, our entire solar system, from the orbit of Mercury to well beyond Pluto, could fit inside it, with room to spare. Now imagine something else. Imagine replacing Sagittarius A star with TON 618. Same location, same distance from Earth. The gravity alone would dramatically reshape the inner Milky Way. But the light would be overwhelming. The quasar powered by TON 618 would outshine every star in our galaxy combined. From Earth, it would appear many times brighter than a full moon. The night sky would vanish. Stars would fade. The galaxy above us would be drowned in a permanent cosmic glare. This is not science fiction. This is scale. TON 618 is not merely the largest black hole we know of. It represents a regime where intuition collapses, where familiar comparisons fail. And yet, even this enormous size is only the outer boundary. Because beyond the glow, beyond the disk, beyond the jets, lies the true edge, the point of no return, the event horizon itself. Part 5. Where escape ends. The event horizon is not a surface. It is not a wall. It is a boundary in space-time itself. A point beyond which the future leads in only one direction, inward. From far away, a black hole appears simple. dark, spherical, silent. But as you approach the event horizon of TON 618, the universe begins to behave strangely. Light no longer travels in straight lines. Photons curve. Some orbit the black hole, circling again and again before finally falling in. To a distant observer, this creates a glowing halo, a ring of distorted light wrapped around perfect darkness. Not because the black hole emits light, but because it bends the universe around it. Time also changes. Near the event horizon, seconds stretch, processes slow. To someone falling toward the black hole, time feels normal. But to an observer far away, that person would appear to freeze, hovering at the edge, their motion slowing, their image dimming, their light stretched thinner and thinner. This is gravitational time dilation, time itself being pulled apart by gravity. At the last stable orbit, the black hole would dominate the sky, a horizon of absolute darkness, encircled by fire. Beyond that orbit, nothing can remain in balance. Any matter, any light, any structure is doomed to spiral inward. As you move closer, colors begin to change. Light climbing out of the black hole's gravity loses energy. Its wavelength stretches. Blue becomes red. Red becomes infrared. Infrared fades into darkness. To your eyes, the universe would appear to bleed its color away. Not violently, but gently, as if reality itself were growing tired. This is not destruction in the explosive sense. It is erasure. And beyond the event horizon, there are no images, no signals, no observations, only equations pointing towards something we cannot describe, a singularity. Part 6, where physics breaks. Beyond the event horizon, all paths lead inward. There is no stable orbit, no outward direction, no return. According to general relativity, everything collapses toward a single point, the singularity, a region where density becomes infinite, where space-time curvature has no upper limit, where the equations stop giving meaningful answers. This is not because the singularity is magical. It is because our theories are incomplete. General relativity works extraordinarily well on large scales. It predicts black holes, gravitational waves, time dilation. But it was never designed to describe the quantum realm. At the singularity, gravity is compressed into a volume smaller than an atom. Quantum effects can no longer be ignored. And yet, we do not have a working theory of quantum gravity. So the singularity is not a place we understand. It is a warning sign, a signal that we have reached the edge of our knowledge. TON 618 pushes this edge harder than almost any other object. Because the more massive a black hole becomes, the more extreme its interior must be. The greater the pressure on space-time itself, the deeper the breakdown between what we can calculate and what actually exists. This is why black holes like TON 618 are not just astrophysical curiosities, they are laboratories, natural experiments run by the universe itself, testing our theories far beyond the conditions we can recreate. And in the case of TON 618, the experiment reveals something unsettling, because even forming a black hole this massive appears to be a problem, not at the end of its life, but at the beginning. How did something like this grow so large, so fast? That question leads us to the greatest mystery surrounding TON 618. Part 7. How did it get this big? Black holes do not begin their lives as giants. They start small. The earliest black holes are thought to form from the remnants of the first massive stars. Stars dozens, sometimes hundreds of times more massive than the Sun. When they collapse, they leave behind black holes with masses of a few tens of suns. From there, growth is slow. Black holes gain mass by pulling in gas, by swallowing stars, by merging with other black holes. But none of this happens instantly. There are limits. As matter falls inward, it heats up. That heat produces radiation, and that radiation pushes back. This creates a natural speed limit on how fast a black hole can grow. It is called the Eddington limit. Even under ideal conditions, a black hole growing at this maximum rate needs hundreds of millions of years to reach supermassive scales, billions of years to reach the largest ones. And yet, TON 618 already weighed tens of billions of suns when the universe itself was still young. There simply should not have been enough time. This is the growth problem. Standard models struggle to explain it, so astronomers have proposed alternatives. One possibility is that TON 618 did not start small. Instead of forming from a single star, it may have formed from the direct collapse of an enormous cloud of primordial gas. No star, no explosion, just gravity overwhelming pressure all at once. Another idea suggests the early universe was far more chaotic than we imagine. Dense environments, rapid mergers, black holes feeding continuously without interruption, growing faster than anything we see today. But each explanation comes with its own problems. Direct collapse requires very specific conditions. Extreme feeding should leave signatures we do not clearly observe. No single theory fits cleanly. TON 618 remains an outlier, not just large, but uncomfortably large. Its existence suggests that either the early universe behaved very differently than we think, or that our understanding of black hole growth is missing something fundamental. And this is why TON 618 matters. Not because it is terrifying, but because it is informative. Because it exposes the cracks in our models. And through those cracks, we glimpse a deeper truth about the universe. Part 8. What TON 618 teaches us about the universe. As extreme as TON 618 is, it is not just a cosmic monster, it is also a tool. One of the most powerful probes we have for studying the early universe. Because quasars shine so brightly, their light travels across billions of light years. On its way to Earth, that light passes through vast regions of space, through clouds of hydrogen, through filaments of gas, through the invisible structure that holds galaxies together. Each time the light passes through matter, it is altered. Specific wavelengths are absorbed. Chemical fingerprints are imprinted into the spectrum. By studying these subtle changes, astronomers can reconstruct what the universe was made of long ago. They can measure the abundance of elements only a few billion years after the Big Bang. They can trace how matter was distributed, how the first galaxies formed, how cosmic structures grew from nearly uniform gas into the complex web we see today. In this way, TON 618 is both destroyer and historian. It consumes everything that comes too close. Yet, its light reveals the history of the cosmos itself. Without objects like this, much of the early universe would remain hidden, too faint, too distant, too silent. Quasars illuminate the invisible. They turn darkness into data. And TON 618, because of its sheer power, acts like a beacon from the deep past. A signal saying, this is what the universe was once capable of. It reminds us that cosmic history was not smooth or gentle. It was violent. efficient, capable of building structures far larger and far faster than we once believed. And yet, even with all this light, TON 618 remains fundamentally unknowable, because the brighter the quasar, the deeper the shadow at its center. We can study the glow, we can measure the mass, we can model the surroundings, but the core itself remains hidden, forever beyond reach. Which brings us to the final perspective, what it means to look at something this extreme and still not understand it. TON 618 is not frightening because it is destructive. The universe is full of destruction. Stars explode, galaxies collide, worlds are erased. What makes TON 618 unsettling is something deeper. It exists at the edge of what we can explain. We see its light, we measure its mass, we model its influence, and still, it refuses to fit neatly into our understanding. It tells us that the universe was capable of building something immense very early, something too large, too fast, too efficient. And if our theories cannot explain that, then the fault is not in the universe. It is in our assumptions. When we observe TON 618, we are not just looking at a black hole. We are looking at the boundary between knowledge and ignorance, at a place where equations still work, but intuition fails. Somewhere out there, more than 10 billion years away, a quasar continues to blaze. Not for us, not as a warning, but as a reminder that reality is under no obligation to be simple or comfortable or fully understood. And yet, despite that distance, despite that darkness, we can still detect its light, still ask questions, still refine our models, still learn. TON 618 does not end our understanding, it sharpens it. Because every time we encounter something we cannot yet explain, we are reminded why exploration matters, why curiosity persists, and why the universe, no matter how vast or how indifferent, is still worth trying to understand. Thank you for taking this journey to the edge of gravity and understanding. TON 618 is distant, ancient, and unreachable, but its light still finds us. If this story made you pause or feel the scale of the universe a little more clearly, you can share that thought in the comments. If the video was worth your time, a like helps the channel continue. And if you want to keep exploring the quiet extremes of the cosmos, you're welcome to subscribe. Some objects don't offer answers. They offer perspective. See you in the next one.